All right, good morning, geometry. So today we're going to be doing the week 6 notes, which if you have found this video, you've probably found the notes because they're posted together in Schoology. And week 6, we're actually going to start getting into unit 3. So we got through unit 2 real quick. And the week 6 notes, these ones are properly labeled week 6 this time, because last time I know they were labeled week 6 when it was week 5. It's only 4 pages, so not too bad. And today in this video, we're going to get through the first 2 pages. So if you're watching this video, I'm not concerned about you, but I know that a lot of people were like, oh, I don't watch those videos. And I'm like, you're missing half the class if you don't watch the videos. Okay, so let's get into it. And this unit is pretty much all about triangles and properties of triangles. And I remember when I took geometry, triangles are the big thing that I remember because there's so much to do with triangles and all these identifications and classifications and theorems and just all that. All right, so when we classify a triangle, we always want to give one side and one angle description. So do you need to do this? It says you always should. And while I agree, we're going to see soon that there are some cases in which you just don't need to do that because if you know the side classification, then you know the angle classification as well, or vice versa. All right, so we have our classifications of triangles by the sides, and these are the big 3. These are the 3 that we're going to see the most. We're going to see classification by sides more often than classification by angles. And these are the only 3 types of triangles that we would see, or triangles classified by their sides at least. So we got equilateral, which means all sides are congruent. So I'm going to draw myself a triangle here. And those sides all look about the same length to me, about the same measure. So to mark that they're all congruent, I'm going to put those little tick marks through each of the sides. So now I know that the first side is equal to the second side is equal to the third side, and they all have the exact same side lengths. The second type of triangle we're going to see is isosceles triangle. And I know that this one is hard to spell, hard to remember. The difference between isosceles and scalene always messed me up when I took geometry the first time around. But isosceles means that at least 2 sides are congruent. So what that's going to look like is a triangle that has 2 sides that are congruent, but maybe that third side is visibly, clearly a different length. So we can see that these 2 sides are the same measure here, but that third side down at the bottom isn't. So this is what an isosceles triangle is going to look like, approximately. And notice that the definition says they're at least 2 sides congruent. So an isosceles triangle has 2 sides congruent. An equilateral triangle has 2 sides that are congruent, but it also has a third side that's congruent as well, meaning that an equilateral triangle is a special kind of isosceles triangle. So I'm going to label this as special isosceles, I-S-O-S-C-E-L-E-S. And then a scalene triangle is a triangle where none of the sides are going to be congruent. None of them are the same length, and honestly, most triangles that we do see are going to end up being scalene because the chances that sides are the same length, pretty slim. But a scalene triangle would look something like maybe this. I'm going to straighten those out. So there's a scalene triangle. And clearly we can see that none of those three sides on that triangle are going to be the same length. And we don't have to mark this with any measures because, or any of these little tick marks, because we know that they're not going to be the same. So there's no point. And then we have classifying our triangles by the angles. So the first one we have is equiangular. And equiangular means all angles on that triangle are going to be congruent. So what that's going to look like is a triangle and this triangle is going to have all three of its angles with the same measure. So we mark it with those little curves on the inside to mark that it's the same measure. Then we have acute triangles, which means all angles are acute. So an acute triangle is going to have, maybe I'll just, yeah, there. So I don't know what the measures of those angles are, but I can see that none of those are greater than 90 degrees, so that's an acute triangle. And we'll be coming back to these in a minute when we get to the next page, because we're going to learn something or maybe review something. I don't know if it's new or review for some of you, that will apply to these. An obtuse triangle means one angle is obtuse, and there can only be one obtuse angle within a triangle. You cannot make a triangle with more than one obtuse angle inside it. So an obtuse triangle would look like this. We can see that that angle there is clearly obtuse, but then the other two angles are very acute. All right, and then the last one is a right triangle. So in a right triangle, we have one angle is going to be a right angle. So there's my right angle. Dang it. Okay, there's my right triangle. And we can see that that angle down there in the left corner is right angle. So we're going to mark it with that little square. And we will always see right triangles marked with a little square, or almost always. So you'll know when it's a right triangle. So as I was saying, up here, an acute triangle is going to have all angles acute. But if I look at an equiangular triangle, it's always going to look pretty much exactly like this. There's no way I can make it with different sized angles and still have them all be the same measure, because then it wouldn't look like a triangle. So these angles in this equiangular triangle are all acute angles. So just like the equilateral triangle was a special isosceles triangle, an equiangular triangle is going to be a special acute triangle. And that brings me to my next point. So if all three angles of the triangle are the same, so if it's equiangular, then it has to be equilateral as well. The two must always coexist. So I don't need this. Equiangular and equilateral go hand in hand. And earlier, when we started the notes, when I was saying that I don't always agree with the definition, I don't always agree that you have to say one side and one angle, it's because of this. It's because saying equiangular equilateral is redundant. Because if we just say equilateral, that tells me that it's equiangular as well. If we just say equiangular, that tells me that it's equilateral as well. So in my opinion, if a triangle is equilateral or equiangular, you don't always need to say both. But for the purposes of today, I don't know if the activity I have you guys doing after this has any equilateral, equiangular triangles, but if it does, use both. But from here on out, I really don't need you to. But that's the only one. The others, you would have to say like, oh, it's an acute isosceles or a right scalene triangle. Okay, so with isosceles triangles and right triangles, and only these two, only isosceles and right triangles, there are special vocab terms that are going to apply. So let's see. Here's my isosceles triangle. And an isosceles triangle has these two sides congruent. And these two congruent sides are both called legs. So that's a leg. And this is a leg. And then the third side, the one that isn't congruent, is called the base. The angle at the top, the angle that is like across from the base, that is called the vertex angle. And then these two angles that are across from the legs. So there's that one, and there's that one. And I'm going to mark them both with two curves. Because in an isosceles triangle, not only is it going to have two legs that are congruent, it is also always going to have two angles that are congruent. So if we see two congruent legs in a triangle, you know that the angles that are across from those legs are both congruent as well. So that means these two angles here at the base are both congruent. And the name for these angles is base angles. So those are my base angles right there. And all of these vocab terms apply only to an isosceles triangle. You may see the word base with other triangles, but the base, when it's seen in other triangles, is basically just going to mean like the one that's on the bottom. But with isosceles triangles, it specifically means the one that isn't congruent to the other two. All right, and then we have right triangles. And the vocab terms that go with right triangles, I don't know if you guys have learned this word that I'm about to teach you. So it's a right triangle, so first thing I'm going to do is mark it with the little square. And the two sides that are next to the right angle, these are both referred to as legs, yet again. So just like with the isosceles triangle, these are both legs. That's a leg, that's a leg. And the side that is across from that right angle, this is the word that I don't know if you guys have learned before. This is the hypotenuse. Hypotenuse. T-E-N-U-S-E. Hypotenuse. And the hypotenuse is always going to be the longest side of a right triangle. And triangles that aren't right triangles will not have a hypotenuse. The hypotenuse only exists in right triangles. So just keep that in mind. All right. And then we have these theorems and rules about triangles. So the interior angles of a triangle just means the angles that are like inside the triangle. So as we can see here, it's like, oh, I was looking at something different. Okay, but yeah, it's like the, they labeled them with the eyes to mark that they're interior angles. And the exterior angles are going to be, like, if we were to continue each of these lines, like they did there, then the exterior angle would be this angle here. So that's the exterior angle. And we can see that the interior angle and the exterior angle there, right next to each other, on the same line, which means they form a linear pair, which we've learned before. And linear pairs will be supplementary. So always keep that in mind. That if you were to extend the leg of a triangle, and then we have an exterior angle formed, and we have the interior angle, those two angles are going to add up to 180 degrees. Likewise, that's an exterior angle, and that's an exterior angle. And like these two here are going to form a 180 degree angle. They're going to add up to 180 degrees, and so are these two here. I don't know if any of these angles are going to be congruent, but I know that the interior and the exterior angle that it's right next to are going to add up to 180. And on this triangle over here, I'm going to go ahead and label the interior angles just like it did there. And the exterior angles, but I'm also going to continue this side of the triangle to both sides. Okay, so now I'll look at this angle here. I formed a new exterior angle there, as well as the original one that I had. And notice that these two exterior angles are vertical angles because they're right across from each other, meaning that these two are going to be congruent. And this angle that's formed like vertical of the interior angle, it doesn't really have a name. It doesn't have anything special about it. It is vertical to the interior angle, but you know, we're not going to worry about that too much. We might need to use it in some problems, but I don't know. And I'm going to do pretty much the same thing on all three angles of this triangle now. So two exterior angles are formed there if I were to continue both lines of that triangle. But as always, they will form a linear pair. All right, so next we have the triangle sum theorem, which is the first theorem we're really learning with these triangles. And the triangle sum theorem states that the sum of the measures of the interior angles of a triangle is 180 degrees. So all that's saying is the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. So let's see. Let's say that angle B here is 41 degrees. And angle C here is going to be 67 degrees. And angle A, that can just be x. We want to solve for that. So if I see something like this, if I know two of my angle measures, I can basically just plug it into here. So that measure of angle B is 41. The measure of angle C is 67. The measure of angle A is x. So x plus 41 plus 67 equals 180. I'm going to solve this problem for x now. So I start by combining my like terms on the left side. So I have 41 plus 67 gives me 108. So I have x plus 108 equals 180. And then I'll subtract 108 from both sides. And when I do, I get x equals, what is that, 72? Yeah, I believe that's 72. So that means the measure of angle A there has to be 72 degrees. And this is always going to be true of every single triangle. The interior angles have to add up to 180 degrees. All right, so now that I learned that, instead of going on, I'm going to go back up here real quick because there's something I want to talk about with these classification of triangles by angles. So since I know that a triangle has three sides, three angles, and the interior angles always have to add up to 180 degrees, that means that in an equiangular triangle, then I just have to take 180 and divide that by 3 to determine what the measures of those angles are. So in an equiangular triangle, the measures of the angles, I'll draw myself a new equiangular triangle here. So the measures of the angles are always going to be 60 degrees because 180 divided by 3 is 60. So that's 60, this is 60, this is 60. In an equiangular or equilateral triangle, we always, always, always know that the measures of the angles have to add up, or add up to 180 degrees, and therefore they must be 60 degrees in an equiangular or equilateral triangle. Tripping over my words a little bit, sorry. So in an acute triangle, again, I don't know like what the measures of these are. I'll just write some in. We'll say that this is, that looks like it could be like 35 to me. And maybe this one would be 75. And 35 plus 75 is 110. So that means that this has to be 70. And we can see those are all less than 90 degrees because remember, acute means less than 90 degrees. And in an obtuse triangle, we have one obtuse angle. So let's say this is 120 degrees. And then these two, we'll say that is 20. And this is 40. And once again, those three numbers add up to 180. They always have to add to 180. Now, when I was going over the obtuse triangle, I said that there can only be one obtuse angle inside a triangle. I will give you a bonus point if you can like send me messages on Schoology or something and explain why there can't be more than one obtuse triangle or more than one obtuse angle within a triangle. So if you can tell me why, I'll give you a bonus point, and it has to do with the triangle sum theorem there. All right, and we're just going to skip over the right triangle because we already know it has 90 degrees and then two acute angles. Okay, the next one is the exterior angle theorem. So the exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. That probably makes 0 sense right now. So let's break this down. The measure of an exterior angle, so we have our exterior angle there, is equal to the sum of the measures of the two remote interior angles. So the remote interior angles, let's think about that. Remote, so like think of like a remote control. It means you're away from the TV or whatever it is you're controlling. So the remote interior angles are going to be the ones that are away from the exterior angle. So there's an interior angle, there's an interior angle, and there's an interior angle. But my two remote ones are going to be this one and this one because they aren't touching the exterior angle. These are my remote interior angles. So basically, if I add up these two angles, then they should equal this exterior angle here. Of course, I could always do this interior angle and then add it to the exterior angle to make 180, or just 180 minus whatever that interior angle is. But sometimes we're not going to know that interior angle. So you could like use the triangle sum theorem to solve what it is, and then use the linear pair postulate, or you could just use the exterior angle theorem to determine the exterior angle without having to determine the interior angle that's right next to it. So as an example of that, to like put what I just said into mathematics, I guess, we have our triangle that has 84 degrees, 62 degrees, and y. We don't know what y is. But the exterior angle theorem tells me that it should be the sum of the measures of the two remote interior angles. So that means y has to equal that 84 plus that 62. Therefore, y has to equal 84 plus 62 is 146 degrees. So that would be all we would have to do. Now, as I was saying earlier, we could do this in 2 steps. So if you don't remember the exterior angle theorem, another way you could do it is, so I have the 62 and the 84. I know that the third angle, when added to these two, has to add up to 180. So I have my calculator next to me. I'm going to do 180 minus 84 minus 62, and I get 34, which means that this angle here has to be 34. Now I have that this 34 and this y form a linear pair. Therefore, they're supplementary, and they're going to add up to 180. So I would do 180 minus that 34, and I would get y, which would once again be 146. So either way you do it, it works, but it's just easier to work with the exterior angle theorem because it's only one step. So the second example, we're given the exterior angle, but these two remote interior angles we're not given one of them, we're given the other one. So that means that we're going to have 138, which is that exterior angle, is going to equal z plus 32. And to solve this, all I have to do is subtract that 32 from both sides. So when I subtract 32, that's going to give me 106 equals z. Therefore, z is a 106-degree angle. Okay. And the last thing we have today is this corollary to the triangle sum theorem. So we already learned the triangle sum theorem. And a corollary, that's a new word that we haven't seen yet. So what a corollary means is it's like an additional rule after a first rule is proven. So like once they proved the triangle sum theorem, they were like, oh, okay, now that we know this, well, now we can also say this rule about these right triangles, because that's what this corollary is about. So a corollary is just an additional rule. So yeah, additional rule after first is proven. Because I already went over the definitions of theorem and postulate. Now we have corollaries, and a corollary is just an addition, pretty much. And this is the last part of the notes we're doing today. So the corollary to the triangle sum theorem is that the acute angles of a right triangle are complementary. So remember, complementary means they add to 90 degrees. So in this right triangle, this ABC, C is my right angle, and that's saying that A and B, which are my two acute angles, have to add to 90 degrees. So the measure of A plus the measure of B has to add to 90 degrees. And basically, the reason that that is because I know that all these angles are adding to 180, right? And if that C is 90, 180 minus 90 is 90. So that means that the A and the B have to add up to the other 90 degrees. So the first 90 degrees comes from that C. The second 90 degrees comes from the A and the B. All right, and that is pretty much it for today. Please use these notes, and I'm sure if you've taken these notes, you have like been using them in the past, which I appreciate, but now that notes are a grade, like some people's grades are suffering, and I don't want y'all to fail. Real quick, I also want to go over just the worksheet that I have you guys doing. I left it in Schoology. It looks like this. So this first part, I could see it messing some people up because it just seems way too easy, because it is. So we want to classify these triangles by the angles. If it has three acute angles, remember, it's an acute triangle. It literally says the word right there. If it has one obtuse angle, it is an obtuse triangle. If it has one right angle, it is a right triangle. And if it has three congruent angles, it is an equiangular triangle. And on this, you just need to classify the given triangles by its sides, or by its angles, I mean. And then you're going to do the same thing with the sides. Y'all can fill in these blanks here. Yeah, you will be doing this same stuff, the same sort of classification there for like problems 9 through 14. And then on the next page, these were actually two separate assignments that I spliced together. The triangle sum theorem says that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. And the exterior angle theorem says that the exterior angle formed by extending any one side of the triangle. Oh, no. It's just saying an exterior angle was formed. Okay, yeah, I thought that was the definition. Okay, an exterior angle is always equal to the sum of the two non-adjacent interior angles. So the measure of angle 1 there is equal to the measure of angle 2 plus the measure of angle 3. And I kind of wish they didn't use numbers to label the angles here, because that just kind of makes it look like a degree measure. But if you see like a single digit number for, I think, all these problems, yeah, in all these problems, any single digit number just means it's like an angle measure, or not an angle measure, but like an angle label. Right, so you would be doing those 7 problems as well. And that's the assignment and the notes for today. Thanks for watching. I'll see you guys tomorrow.